The second one is this one. Okay, sorry. The second one is a slow speed. Okay. And this one is a tough topic, but spend a lot of time, but I try to do my best. Okay, this is my name. Just call me Han. I'm P in Texas. Okay, who is the lowest plastic? Plant-based, privately owned, diversified, very diversified. All the mechanical, except the pump, gearbox. Even the gearbox, we manufacture this ourselves. Others, electronic, college, hospital. And we are in Texas is the biggest one. Point Comfort, 19 production units. Oliphant, PVC. Formosa is the second largest PVC in the world. We have 3,500 rotating equipment in the program. You can imagine there's much more than this. Okay, oil lab, outsource, oil scope, ultrasound, and also do the thickness check. This is polymer production application. This is the last process before we come to count the pallet. And this needed a lot of additive. For this one, the bumper needs to be tough. The character must be some additive to change the character. This one, no matter how purified this water, if the water bottle don't have any treatment, anti-oxidation or the anti-static, if you spring the water, is the bottle keep turning yellow, or it have dust collected on it, even no matter how quality is good, you don't like to drink. Okay, this one is wire condition monitoring. The desk is very familiar with this on this one. First one, infrared. Very possible the first one is the last one, and I run only once and fail. Low don't mean none. Still have possibility. Okay. And the life. How long is life? The longer, the better. No machine lasts forever. Eventually it will fail. But when? Who governed this curve? Only one rule. The Murphy rule. When anything can go wrong, it will. Okay. How long it can run? This is API spec. Gears, 5 years. Compressor, 5 years. Pump, 3 years. But remember this one. Only for design criteria. Only for design. If you put it in the field, total different story. Character of slow speed. Slow RPM, weak signal. If we cross the bumper, it is the same bumper. But if we cross over this with different speed, fast speed, boom. But if you run over very, very slow, you are very hard to detect. There is even a bumper underneath. Marble shaft RPM. Very complicated component. The example I will use how complicated it is. Variable speed, variable load. Number 5. Even it is run very slow, but the fail is not sweet. It is always silent and violent. Okay, you know what I'm talking about, huh? Very slow. So that's the target. Portable. You can hear, you can feel, you can visually see a lot of things. And you can smell. Human sensor. Negatives. People dependent. If somebody quit, and also human error. Same spot, few inches away. Only not exactly same angle. Contact force difference, variation, and the time consuming. That is put on the gearbox. Before it was here, and after we put it here. And this one, only just few inch difference, it can create 42% change. And it is, for portable, it is hard to keep exactly repeated data. And the consistent data critical is very critical for slow speed. Equipment is innocent. No equipment is equal. So many different designs. Same similar design with variation. Baseline start from wide range. Vertical configuration. Horizontal direction. But it is only support on one end. The other end, nothing. Different installation. Different working environment. Cadillac. Solid concrete, rubber, very small footprint. This is very familiar with this one. This standard uses 0 to pick, use inch per second. This is very simple. But this one, I don't like this very much. Okay. The next one will show you why I like the other one. Because it don't give you another important sense. The velocity parameter don't independent of the frequency. This one this one give every 2 times 6 decibel as a secondary change and 9 severity level. The next one gives you much better. This one is flat, regardless of the frequency. You know this range, they are constants. But they also give you another sense. On the low frequency range and the high frequency range, it will attenuate. Much better, give a better sense. But before it is 2 times 6 decibel, but this one use 2.5 level, 8 decibels as the change. And the rigid, lower lung, but higher lung. This one is another one. Okay. Frequency range is more detailed by the compressor pump, different type. 3 level only. But on vertical, different level. Even we measure the same vibration, if we measure on a different direction or different level, they are said not the same, never the same. And this one also, it depends upon what job it is doing. It's tooling machine. If at a different stage, it will use different level. And consider foundation, also isolation. And the soft, high and higher, different, another number. Okay. The end user, what is the severity criteria to apply? The end user and the equipment are under operation. This criteria interpreted the machine health to the end user. Okay, this is something between the end user and the equipment. Let the user understand what is equipment, how is its status. But I just make some example. There are so many standards and criteria. They are different. They don't agree with each other. The second one, they are all the same. If you apply their standard, they don't pay for your production loss. This one, API, variable. This is pump character, this is vibration level. Some zoom, you must be avoid. The other zoom, sweep zoom, you must best efficiency point, you better run within this range. And use different level. If it is normal, use this level. If it is abnormal or out of the range, you can use another criteria. But this is only give you a concept, multiple alarm. But this will give you understand a concept only, no specific number was given. This one, API, this one gives you more specific number. Okay, different type. Okay, this will give you overall, but this one must be spec, need this one spec. Also FFT, case reading and the non-contact probe, different spec only, different spec. Within, if it is within best efficiency point. If it is outside the best BEP point, another spec. If it is above 3600, another criteria, you must refer to the another plot. Very complicated. Okay. Machine is innocent. Okay. If it's under different operation, most time, not what it's designed to do, but what we want them to do, most time. And the trend swing up and down, never stable. Equipment is not innocent as well. Vibrate, corrosion, overload. But this is not too bad, 45 degree only. And the winner is 90 degree. Okay. Equipment is innocent, vibration is innocent. Carbon tree don't equal abnormal. All can affect the vibration, and this is our target. And also predict the innocent. Predict don't stop, wear out. Predict only eliminate surprise. This one is the polymer process. This is just cut section. This polymer process changes the recipe very often and under variable production rate. This one, the linear range is 0.1, 3 times ratio. And this one's the Meyer index. This Meyer index and the viscosity is just reverse number. On the viscosity, on the ASMT, it is 1238 spec. It's just it's 445. It's usually 445. It depends upon a given volume and how long it takes to pass through all the liquid. The longer time means higher viscosity. But the Meyer index, according to the ASMT 1238, they are different. Convert, reverse. It gives you 10 minutes. If 10 minutes, how much flow can pass through this calibration instrument? If it is low, if it is only 1 gram and 2 gram, which one have higher viscosity? The 1 gram. So if this number is just indication is the reverse to viscosity. If the lower number, the higher viscosity, the higher molecule. This one is even higher. This one is much softer. This one I convert this one to the Excel to become the DCS. This one, okay, I put all the parameters together. This one here